Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Green Booklet Practice Test 1, specifically Unit 34, questions 104 to 105. And in this unit, we're going to take a look at the bacterial population in the digestive system of a developing fly. Now, this unit was designed to deceive you. So you've probably already noticed, if you take a look at the y-axis, you see that they've got at the top, it's 10 to the power of 9, 10 to the power of 8, then 10 to the power of 7, but the boxes drawn there are the same size, but that's not true. It's a logarithmic scale. So let's read the x and y axes correctly. This is why we always tell students, make sure to read the axes correctly. So the bacterial population is on a logarithmic scale, but it's not drawn to scale in the figure. I've kind of tried to draw it to scale here. Obviously, it's not to scale, but it shows you the boxes in terms of how big they should be for the differences between the population numbers. So it is kind of more accurate to draw it this way. But if they did it this way, where's the fun in that? Everybody will get the correct answer. So it's kind of like a little trick here. So just take an example. If we have 10 to the power of 9 subtracted by 10 to the power of 8, we're left with 900 million. Whereas if we go down the scale, we do subtraction of 1 million from 100,000, that's only 900,000. But you can see in the table that they provide, or in the figure, the change looks the same, but it isn't. That's the trick here. So if we take a look at the first question, it says, of the following, the greatest decline in salmonella numbers occurs during, so salmonella is represented by the 1 in the graph. So let's just try to draw it here. It's at 10 to the power of 7, so it's going to be about 10 million. And it's going to go down, so in between here and here, and it's going to go down to, it goes all the way down to about the 7th day. So from the 4th to 7th day, so let's just draw something like that. You can see that a decline from, say, that looks like day 4 to day, let's say, 5 is going to be 9 million. Whereas a decline from, let's say, day 6 or 7 is going to be from 10,000 to 0. So that's a 10,000 number decline, whereas up here at the top, it's going to be about a 9 million or whatever the value is going to be. But you can see that the more higher you go up this graph, the greater the decline is going to be. So therefore, the answer for 104 has to be the earliest day possible. So that's why the answer is going to be A, the 4th day. So if we move on down to the last question, it says, which of the following is the best estimate of the reduction in size of the normal bacterial population between drenching and day 7? So you can see the normal bacterial population represented by 2. So if we go from, it's going to be about, let's say, 10 to the power of 8. So it'll be about the 100 million mark. So let's say it's around here. So drenching, it's day 4 or something. And it's going to go down to day 7. So and it's day 7 is about, I'd say 10 to the power of 6. So let's say a million. So from drenching to day, so let's say drenching is going to be 100 million. Sorry, it's 100 million. So it's 8 zeros. 1, 2, 3, 4, 5, 6. Oh, sorry, that was correct. And then we've got our day 7 is going to be 1 million. So 10 to the power of 6. 3, 4, 5, 6. So you might see it as 10 to the power of 8 and 10 to the power of 6. Some students might say, oh, let's just subtract the 2 and we're going to get our value. But remember, no. With scientific notation, you can only subtract the 2 if it's a times, or so if it's divided by. If it was divided by, you'd subtract it. But this isn't the case. We're just asked for the difference. So if we're looking for the difference, it's just going to be 100 million minus a million, which is equal to 99 million. So therefore, when it says what is the bacterial population, what's it going to be closest to, the answer has to be 100 million. So the answer is D. So don't get fooled, because some students might get fooled and see 10 to the power of 8, 10 to the power of 6. Let's just subtract the 2. So 10 to the power of 2 is going to be 100, and they might say the answer is A, but that's not correct. It's not A, because you can only, remember with scientific notation, if you times Scientific notation, it's going to be 10 to the 14. If you divide, it'll be 10 to the power of 2. But we're not doing that. We're doing addition and subtraction, in this case, subtraction. So you just got to conceptualize. So if you have any more questions about this unit or any other comments, you can post them in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.